All right, folks, it's Bass Action back in action here. In this video, we're going to go through some examples where the solutions are consistent and independent. Remember, consistent and independent from the first video in this chapter would tell us that there should be one solution, one unique point that the three planes have in common. So on this first one, we're going to jump in and just look at the algebra here. And remember, the first thing that we would do is we would ask ourselves what variable we want to eliminate. In this case, we have a wide variety of signs, so we could easily justify maybe eliminating a z or maybe eliminating a y. I personally like the x's. Even though I don't have any changes in sign, what I can see is that on equations b and c, my coefficients already match, and that's going to make things a little bit easier for myself. Okay, so jumping into this, I'm going to save that easy one for last. So I'm going to, instead of doing a and b, I'm going to do something with equation a. So I'm going to take a -2 times equation A, and I'm going to add that to equation B. When I take a -2 times equation A, I end up with a -2x minus 4y minus 2z equals a -20. And then since I'm not doing anything to equation B, I can just rewrite it exactly as it is. You have to be really careful with these. You might want to use lined paper all the time on these. I'm going to add these together. My x's drop out just as I would have wanted, and that's going to give me a -5y plus a z equals a -25. I'm going to call this new equation equation D. Okay, so now I have an equation in terms of y and z. I want to create a second equation in terms of y and z, remembering at all times I always have to remember to eventually use all three equations. So now I'm going to go back and I'm going to use those equations b and c that I wanted to use in the very beginning. And I don't have to do anything special to those. I'm going to take my equation b, and then I'm going to take a negative times equation c, a -1. So my equation B, I just get to straight up write it again. 2x minus y plus 3z equals a -5. Then a negative times equation C will give me a -2x plus 3y, just flipping all the signs, plus 5z equals a -27. I'm going to add those together, and just as I wanted, the x's will drop out. So I get a 2y plus an 8z equals a -32. And what I notice on this equation is I could make my numbers a little bit smaller. Anytime I can do that, it's kind of nice. So I'm going to divide everything in that equation by a 2. I don't have to, it just makes life a little easier for myself. So I'm going to have a y plus a 4z equals a -16. I'm going to call this new equation equation E. Now what I'm going to do is I'm going to look at equation D and equation E that are both in terms of y and z, and I'm going to think, how can I solve that system of equations? Now I've got a wide variety of choices here, but what I decided to do in the very beginning was I decided to take my equation D, and then I'm going to take equation E and I'm going to multiply it by 5. What that's going to do is that's going to allow me to eliminate these y's. Okay, they already have opposite signs. I know that I don't like to have to work with negatives if I don't have to, so that's a good choice for me. So equation D would be my -5y plus z equals a -25. Then 5 times equation E will give me 5y plus 20z equals a -80. I add those together, the y's drop out. I get a 21z equals a -105. Z is a -5. So now I have solved for z. And now I essentially I think of this as like unraveling the whole thing. If I have z, I can now work backwards and find y. So I can use either of these equations to solve for my y. It doesn't matter which one I do. So I'm going to go ahead and substitute into my equation E. So I'll have y plus 4 times that negative 5 equals a negative 16. So my y equals 4. And then I take those two remaining ones and I substitute back into any of my original 3 equations. I'm solving for x, so equation A will be my easiest. So I'll have an x plus a 2 times 4 plus that negative 5 equals 10. So my x turns out to be 7. So then our final answer we would write as a nice ordered triple. If we were going to write that final answer, we would write it as a nice ordered triple, x, y, z. So it would be 7, 4, negative 5 would be our final answer on that. Okay? Now, we are going to also do some word problems. So on this one, I've already provided the equation for you. We'll do some word problems in class, and you will have to come up with those word problems on your own. So first thing we want to look at is we read this, and what we're kind of looking for are what I call the totals. So for example, we have 49,000 seats. Okay, as I'm reading through this, it says that the tickets for the seats and are in the upper level are $25, so it's going to give us some information there. Upper level seats are $25. Middle level seats are $30. Bottom level seats are $35. Then it's going to tell me that the number of the seats in the middle and the bottom together equals the number in the upper. That part gets kind of complicated. And then when all the seats are sold, it says that our revenue is this 1,419,500. So when we look at our 3 equations, this 49,000 is our total seats, upper, middle, bottom. This revenue number is also helpful, remembering the upper were 25 apiece, the 30 were the middle seats were 30, and the bottom were 35. And then it also said right here that the middle and the bottom together equaled, remember that's an equals, the middle and the bottom together equals the upper. So there's our 3 equations. Now, what I want you to notice on this problem is this is a problem where substitution is actually going to be really easy for us to use on this particular problem, okay? Because what I can see right from the very beginning is that one of my equation has already been solved for a variable. So I can see that u equals this m plus b, which means I can substitute in both of those equations right off the bat. Okay, so the first equation, substituting that in, I end up with an m plus b plus another m plus b, that was from the original, equals the 49,000. Okay, that of course is going to become a nice 2m plus 2b equals 49,000. Anytime you can make your numbers smaller, I would suggest you do it. So m plus b equals 24,500. Okay, I'm going to call this equation equation A. Then I'm going to set up another equation here. I'm going to give ourselves a little bit of a line to help us kind of keep track of some of our work. Then I'm going to go ahead and I'm going to do that substitution into my second equation. So when I do that, I'm going to have a 25 times my m plus b, just subbing in, and then I still have all the rest of the original equation. 30m plus 35b equals the 1,419,500. Start cleaning that up. 25m plus 25b plus the 30m plus the 35b still is the 1,419,500. Continuing to clean things up, collecting my like terms, I have 55m plus 60b equals the 1,419,500. And then if you see it, what we can do is we can divide everything through by a nice 5, again, just making our numbers a little bit smaller for ourselves. And that's going to give us an 11m plus, minus I meant to say there. Nope, I was good, plus 12b equals my, when I divide that through, and you could bust out a calculator, no big deal, 283,900 there. So now I'm going to call this equation B. So now I have an equation A in terms of m and b. I have an equation B in terms of m and b. So now I can either do, again, substitution or elimination. I chose to do elimination here just to combine my two strategies. I kind of like elimination. So I did a negative 11 times A plus B. Again, this is just a personal preference. You could do it a variety of ways if your brain sees a different strategy. So a negative 11m minus a negative 11b equals a negative 269,500. Yes, I used a calculator. Then my equation B, 11m plus 12b equals 283,900. Adding those together, now things start to clean up really fast for us. The m's drop out. The b's, I'm down to just a b, and that gives me 14400. So 14,400 bottom level seats. Okay, our middle seats, okay, and the bottom together. So remember, our middle plus our bottom together is supposed to equal the upper. So we've got, and we can go back to this equation right here. And we've got this 24,000. So we can say even our middle plus our bottom is 24,000 at this point. So we've got our middle plus the 14400. I can say my 24,500. So our middle is going to be 10100. Of course, we can see now at this point that those upper are supposed to be 24,500 from this equation right here. The middle plus the bottom is the 24,500. But if you're still like, wait, really? How does that work? We can take that middle plus the bottom, and if we substitute it back into the very, very beginning, we're going to get right back to that same idea. So this last step isn't really necessary because we already know the answer. But just in case you happen to not see it, I'm going to go back to the very original equations. And if I substitute my middle and my bottom, I will end up, sure enough, with that upper of the 24,500. And those are all of our seats. We'll do a whole bunch more in class, and we're going to keep practicing these and then also learning new strategies for solving the systems of linear equations.